Hello everyone. Today we're going to do our first video on completing the square. Now what is completing the square, you ask? Well, completing the square is the process which turns the standard form of a parabola and converts it into vertex form. So in the past we saw that if we want to go from vertex form to standard form, we just had to distribute, but we haven't talked about how to go the other way. That is because it's a little bit of an involved process, but we're going to be spending the next few days going on, and it actually has a lot of geometric concepts behind it. To begin, we're just going to be taking a look at functions of the form x squared plus bx. And our goal is to turn that into something called a perfect square. That is, we want to find a number, find a value c to make a perfect square. Now what does that mean exactly? Well, let's just think about some geometry. So if we had a rectangle, that would not be a perfect square, and a square, of course, would be a perfect square. Now let's look at how we could represent the square. We could have a 3 here and a 2 here, so we can have side lengths. We could also have values. Say the side of this is 3 and this is x and this is 3. This could also be 3 plus x and this could be 2, but this would also have to be 3 plus x because it's a perfect square. Now let's look at an example. So say we have the function x squared plus 8x. And we want to find a value c that will make it a perfect square. Well, why don't we start by just drawing a picture of this using kind of a rectangle. So how can I represent this using geometry? Well, let's say this line is x in length, and this line is x in length. Sorry, that line will be x in length. And then we'll have another line which is 8 in length. And then we'll have another line which is also x in length. So we look at this, rectangle I've made. This is a good representation of our parabola as it is because the area of this here would be x squared and the area of here would be 8x. So the total area of our function would be x squared plus 8x, which is what we see here. So now we want to figure out how can we manipulate this to turn it into a perfect square. What I'm going to do is we're going to split this down the middle, which will make this, if we draw it, we'll have an x here and an x here, so this will still be x squared. But then we'll only have 4x here, because this length will now be 4. So we'll have 4x. And what do we do with that half? We're going to put it right here. So that means this length is now 4, and we have another 4x. So now we have a gap here, which I'm going to do in green. So if we found this gap right here, then we would know what C is. Well, let's see what happens. Let's see 4 times 4. This side length must be 4 if this side length is 4, and this one must be 4 as well. So that means our area is 16. So look at that. We found a value that if we add to this expression, we can make this into a square, when before we could only make it into a rectangle. So if I write x squared plus 8x plus 16, then presumably I can turn this into a square. And in fact, if you look at the square, the top is the expression x plus 4, and the side is the expression x plus 4. So let's try factoring this really quickly. So it's going to look like two things multiplied together. We're going to have an x here and an x here. And we know that it's going to be plus p and plus q. And we know that p times q is equal to 16, and p plus q is equal to 8. And if p equals 4 and q equals 4, well, that would work quite nicely. So it looks like these are going to be 4 and 4, so we have x plus 4 squared, which would be our expression. So that matches up perfectly with what our square looks like. So let's generalize this a little bit. Say we have x squared plus bx, where b is just some constant, and we want to make that a square. Well, once again, let's make a rectangle which represents this. We'll have one that has a length of x on two sides, which will give me x squared. And we'll have something that has a length of b here, and then the side length will still be x. So the area of this part will be bx. So that matches. The area is x squared plus bx, which is what our function says. Now I'm going to split this down the middle, which is going to be, I'm going to take b over 2. So then I'm going to get a new shape where I have x, x, and then x squared. Now I'm going to rewrite this like so, where this value, the side is now b over 2. And so I have, I'm going to make that a little bit bigger. So it's going to be b over 2. And inside I'm going to have b over 2 times x. And then I'm going to have that down here as well. Then this is going to be, I'm going to have a side length of b. So then there's a b for this side and x for this side. So I'm going to have b over 2 times x. Now what's going to go in here? B over 2. So this value is going to have a side length of b over 2 coming from here and another length of b over 2 here. So the area inside here is going to be b divided by 2 squared. So this means that whenever you have a setup like this, you can always complete the square by doing b over 2 squared. This will always make it work, and this will always end up giving you a square of this form x plus b over 2 squared. And if you look at this, we have a side length of x plus b over 2, and the other side is x plus b over 2. And of course, the area of a square is one side multiplied to another side. So if one side is x plus b over 2, and the other is x plus b over 2, well then look at that, you have created a square, which we see on the inside. So that's how you complete a square of the form x plus b over x, x squared plus bx. Let's do two example problems. For our first one, we have x squared plus 6x, and we want to complete the square. Well, that means we need to figure out a c value, and that c value will be the value we need to complete the square. Now, we know last time that we need to add b over 2, and then we'll end up with x plus b over 2 squared. We have to add b over 2 squared. So that means that we should theoretically be adding 6 divided by 2 squared, which would be 3. So we would end up with x squared plus 6x, this would be 9, plus 9. And we would end up with x plus 3 squared. Well, let's confirm that using our area model. So if we use an area model, we'd have these lengths would be x. This would give us x squared. This length would be 6. And it would just be a rectangle. So this would be 6x. And then what we would do is we would go and we'd cut this in half. We get x here and x here to get x squared. And then we'd have a length of 6 over 2, which is 3. And this would be 3x. And then we'd have another one that goes there. This length would be 3, because we're splitting this in half and putting 1 on the bottom. And then we need to figure out what goes here, and that's the value we need to add to complete the square. And it'd be 3 times 3, which is 9. So it looks like our value is 9. And then we would end up with x plus 3 squared. And to be precise, we wouldn't say x squared plus 6x plus equals that. We would probably write x squared plus 6x plus 9 is equal to x plus 3 squared. And we have created a square, literally. Alright, last example, we have x squared minus 9x. First, let's see what we expect it to be. So we expect that we should add negative 9 Here we should add negative b over 2 squared and end up with x plus negative b over 2 all squared. Sorry, x plus b, and this should be plus squared. So why don't we see what happens? Well, we see that we have b equals 9, so we'd have negative 9 over 2 squared, which would be 81 over 4. And we would expect to end up with x plus x minus, rather, because it's going to be negative, x minus 9 over 2 squared, because that's b divided by 2 squared. So let's see if the area model confirms that. Well, we're going to have value x here, and we'll get x squared. Now this length will be negative 9. So we have negative 9x, and then we're going to cut it in half, which will give us the x here, x squared. And then we're going to have this length of negative 9 halves, and this will be negative 9 halves x. And then we'll have another one here that's negative 9 halves, and the area is negative 9 halves x. And now we need to figure out the green area. Now, this is going to become, I'm going to write the area out here. It's going to be negative 9 halves times negative 9 halves, because that is what's outside. And this is going to become 81 over 4, which is what we're expecting. So then we're going to say that x squared minus 9x plus 81 over 4. Well, we could factor this, certainly, or we could just look here and see that the side length of this square is x minus 9 halves, and the other side length is x minus 9 halves. So we don't even really need to worry about factoring it, because we can visually see that, of course, when we factor this polynomial, we end up with x minus 9 halves squared. Thank you all for watching. We're going to be doing a lot of completing the squares over this next week, so hope you all enjoy lots of area models. I certainly do.